Very good afternoon, all of you. Very good afternoon to all the online students. Please confirm the voice is audible or not. One second, I'll just fix the camera. All right, so what we have discussed in the last session, what we have discussed in the last class, downcasting is what we have to understand. We were not able to call the specific child-specific methods using the parent type of reference, correct? We'll go through it. We'll start with it. Please go through your notes once. Everyone, please see the program which we have seen in the yesterday's session. Second bench, a little bit shift, please. If you are having bags, please keep it down. Please shift a little bit. Anywhere this side, if 7 students are there, please shift a little bit. This side. Come here, come here. Come here on the fourth bench. Please go through your notes. All right. So yesterday what we have discussed is we came to know that whenever we are writing any program related to the polymorphism, at that time we will be having three different type of methods inside the program. One method will be inherited method, another one is overridden method, another one is child specific method. Using the parent type reference, you can access, you can call inherited methods and you can call overridden methods, but you cannot call child specific methods directly. That word directly is very important because indirectly it is possible. How it is possible? That is by making use of a concept of downcasting. Now let us understand what do you mean by downcasting. Yesterday I think I have just given you the heading related to that. Okay, below that please take down one note first. Take down downcasting. Downcasting is the process of downcasting is the process of downcasting is the process of converting. Downcasting is the process of converting the parent type reference. Downcasting is the process of converting the parent type reference. Converting the parent type reference to the child object. Converting the parent type reference to the child object for calling the child specific methods. For calling the child specific methods using the parent type reference. For calling the child specific methods using the parent type reference. Using the parent type reference. Okay. Now let us understand how we can do this downcasting and what is the real advantage of performing the downcasting. See here what I will do. I will this program we will again analyze, which we have written in the yesterday's session. So one class we have created, that is the developer class. Another class we are having, that is the backend developer class, where we are telling it is extending to the developer class. Next we are having the database developer, which is again extending to the developer class. Next we are having the web developer, which is again extending to the developer class. And then we are having developer application.java. Inside this developer app.java, what we are doing here is we are writing the program in such a way that we are first achieving upcasting, and after achieving upcasting, we are calling the child specific methods of the child classes. But it is not possible. We can only call either inherited method or we can call overridden method. Then sir, what to do? Let us perform the downcasting. Now downcasting means whatever this parent type reference is there. What is the type of DEV? What's the type of it? Developer. What is developer? Parent of backend developer class. Yes or no? So whatever the parent type reference is there, this parent type of reference we have to convert to the child type again. So in which class learn Java method is there? Backend developer class. So here I will tell Dave, I know you are working as a developer type, parent type. Don't behave like a parent type. For this statement, you have to behave like a child type. So here I will mention like this. And then completely, I'll put it in the brackets in this particular way. And then you can see we are able to call learn Java method. So what we have done, this Dave, this also maybe we'll put in the brackets. So this Dave was of what type? Parent type. We are converting this into what type? Child type. And completely I am using to call which method? Child specific method. So here what you are seeing, this only is called as performing downcasting. Is it clear? So what we are doing here, converting Dave, that is parent reference, to backend developer, which is nothing but child object. This is what we are doing here. In the same way, I have to perform the downcasting. Here also. Now tell what we have to do here. We have to perform downcasting. We have to convert Dave parent reference to what? Database developer. So what I should tell here? Tell this Dave I'll put in the brackets. To what type we have to convert it into? Database developer. And this completely I'll put it in the brackets. And then I will tell dot learn SQL method. In the same way, here also I have to do the same thing. First I will copy this maybe. Here also I will tell we are performing downcasting. For performing this downcasting in this statement or for this requirement, what we have to do? We have to convert it into what type? Web developer type. Okay. Here, what I should mention? You tell now. I will write. Tell. Here, what I will tell? Web developer. Here, what I will tell? Dave. And then dot learn HTML. So whatever you are seeing here, this is the syntax of performing the downcasting. And why we are doing this downcasting? What is the use of it? So that we can call child specific methods. Is it clear? So if in case I want to call the child specific method of any class, there is only one way. Bring the parent to the child level and then you have to call the methods. Upcasting means converting child into parent type. Downcasting means bringing parent to what level? Child level. You only see yourself. Assigning the child to parent. See the hand movement. Assigning child to parent is called as upcasting. Okay. Next here, what we are doing? Dave means parent. Converting parent to child is considered as downcasting. If in case I'll execute the program, you can see all the child specific methods are also getting called. Backend developer is learning Java. Database developer is learning SQL. Web developer is learning HTML. Please make a note of this in your notebook. Only this class, remaining other classes will remain as it is same. Whatever the comments are there, please write the comments as it is. It is important for you to understand the program. Done copied, everyone? Also, when you are writing any program in the interview, if any program you are writing on wherever you are writing, please make sure that you also start writing the programs in the format of the comments. The comments are very important. Sometimes because of these comments only you might get the job. Who knows? So don't leave any opportunity in the interview where you can showcase that you are good in technical. Comment is one of such thing which is a very important one, yet very few students will be using it after telling so many times also. So if in case you are using, your chances of getting placed will highly increase. So make sure whenever you are writing the program, you are always writing the comments in the program. And this is one of the very good, I should say, characteristic of a great developer. Without writing the comment, you can never become a good developer. What is the other advantage of writing the comment? Assume that you wrote this program. You have written this particular program. Now, interviewer told you, explain this program, how it is working. Maybe you are not good in such English. You are not good in English. But somehow you have written the comment. You have taken your time slowly, you have wrote the comment. Now, what you have to do? You just have to read the comment. That's all. Your work will be done. Read. Sir, here we are performing upcasting. Upcasting means we are assigning backend developer object to developer dev reference read for this statement. Sir, here I am calling the inherited method dev.attend meeting. Here I am calling the overdone method dev.project. Now I am performing the downcasting. Downcasting means it is converting parent reference to child object. So like this, I am performing downcasting. We are doing this to call a child specific method. Next, I am creating the object. Now here what we are doing, we are again doing upcasting. We are calling inherited method, calling overdone method. So like this, you can just read the comment and your job will become very, very simple. Is it clear with everyone? All of you have written this program now? Okay. Now again, think and tell, in this particular program, do you have polymorphism? Are you having upcasting? Are you having downcasting? Are you able to call inherited methods, overdone, child specific? All the methods are you able to call using paratime reference? Yes. Are you having code redundancy also? Yes, we have code redundancy. See here, dev.attend meeting method, dev.project method. Again, dev.attend meeting, dev.project. Again, dev.attend meeting, dev.project. Are we repeating the same code again and again and again? Yes. So now let us understand that what is the best way of writing a program where everything is happening. Inheritance is there, polymorphism is there, 1:many relationship is there, upcasting is there, downcasting is there. Let us understand this point also, which will become the best way of writing a polymorphic program that you already know. What you have to do here? You have to just create one separate method, and in that separate method, you have to write the program. So here, I'll give you a requirement, something like this. Let us say that there is a class. This class name is a shape class. After this, there is one class. This class name is a square class. There is another class. This class name is a circle class. There is another class. And this class name is a rectangle class. And all of these three classes are inheriting to the shape class. Circle class is inheriting to the shape class. Rectangle class also is inheriting to the shape class. And inside this shape class, two methods you are having. One method happens to be, let us say, a draw method. Another method happens to be find area method. In the draw method, you will just tell drawing a shape. In find area method, you have to calculate the area of the shape. Now in the square class, first thing, we will override find area method. In the circle class also, we have to override find area method. Not only this, in the rectangle class also, we have to override find area method. Along with this, we have to write few more methods. So here I will tell find square perimeter, one method. Next, here I will tell find circle circumference or circumference, or here again I will tell the same thing, perimeter. It is actually circumference, maybe I will tell perimeter. And here also I will tell same thing, find rectangle perimeter. Like this, I want you to write the methods, and finally, you have to create a reference of the shape class, maybe SH. So initially, shape will be of which type, or SH will be of what type? Shape type. This SH should point towards a square, call all the methods of the square, should point towards circle, call all the methods of the circle, should point towards rectangle and call all the methods of the rectangle, and also code redundancy should not be present. So if code redundancy should not be present, what you have to do? You have to create a separate method, and then you have to start writing then you have to complete the program. Is it clear, everyone? I will tell you the requirement. It is drawing a shape. Here you have to tell double is the return type. Not only for find area, find circle perimeter, find rectangle perimeter, find square perimeter method also have the return type as double. So both of these methods return type will be what? Double. So they have to return a double type of value. Please try to do it in your notebooks. Finish it off quickly. Take down example number 2, next example, and then complete it. Don't discuss anything, do it individually. Done, finished everyone? Let us check how we can write this program, and also if in case we'll write the program in that way, how you would have written, will it work or not? Writing the program is not important, writing the working program is important. All right, so here I'm going to share the screen, and let us see the program now. I'll first close all these classes which are not required. Assume that I'll create a new package itself. I'll tell here com.learn or learn polymorphism. Maybe example number 4. I will click on finish. Inside this, I will create the required classes first. So new class. First class we have to create as what? Shape class, the parent class. Next, we have to create another class that happens to be square class. Next, another class, circle class. Next, one more class, rectangle class. One more class, shape application class, inside which main method is also present. Now let us write this program and try to understand that what we have to learn a new thing inside this particular program. Inside this shape class, very first thing that I want to create a method, that is a draw method. So here I will tell void draw. Inside this draw method, I will mention system.out.println. And here I will print a message saying drawing a shape. Next, one more method I will create, void, not void, double, find area method. Well, we also know that we cannot calculate or find the area of a shape. We need a specific shape for this. So here just I will tell return 0.0. Why I am telling a return statement? Because here I have told the return type as what? Double. I will save the program. Next, I will move to the square class. First thing I will tell here extends shape. After this, here I have to override one method. The method which I want to override happens to be double find area method. Now, whenever we are doing this overriding, one more thing, please understand. On this method, you can use one annotation also. What you can use? Annotation that happens to be @ override. So this @ override will tell us that this method is not a normal method, rather this method is a overridden method. And then here I will calculate the area of a square. So maybe here I will tell double area is equals to, maybe here I will tell in this, assume that for this square I will take one variable as side is equals to 5.5. And then here I will mention double area is equals to, what is the area of square? Side into side. Like this, I will find the area, and then here I will tell return area in this particular way. Next, I also want one child specific method. So here I will tell double find square perimeter. And then here I will mention double perimeter is equals to, now here I have to calculate the perimeter. Can you tell me how to calculate the perimeter? 4 into side. And then here I will tell return. Well, what we have to return? We have to return perimeter. Like this I will tell. This is the finding the square perimeter method body. After this, I will go to circle class. Here I will tell extends shape class. Next, inside this, again, two methods we have to write. One method should be overridden method. So here I will tell void. The method name is find area method. Okay, double, sorry. So here I will tell double find area method also. Here I will create one variable double, maybe radius is equals to 5.5, something like this. And then here I will calculate the area. So in this I will create one variable double area is equals to, I will use math.py method multiplied by radius, again multiplied by radius, like this. And then here I will tell return area. After doing this much, I will create here one more method, the child specific method double find circle perimeter. And then here I will tell in this particular method like this, double perimeter is equals to 2 into pi. So math dot pi into radius. And then here I will tell return. What we have to return? We have to return the perimeter. I'll save the program. This is the program we are creating for the circle class. Now coming to the rectangle class. Here I will tell class rectangle extends shape class. Inside this again two methods. One method will be overridden method. So at the rate override I will tell. Next I will tell here double find area method, where I will mention here two variables, double type length is equals to 5.5 and breadth is equals to 8.5, something like this. And then here I will tell double area is equals to length into breadth. Okay. And also I have to return it. So here I will tell return area. Next, I will mention here double find rectangle perimeter method. So here I will tell perimeter method. Inside this, I will mention double perimeter is equals to. Now we have to mention here that what will be the perimeter for the rectangle. What's the perimeter for rectangle? Sorry, 2 into length into length plus breadth. So here I will tell like this, 2 into length and breadth. I will just put it in the brackets. After this I have to return. So here I will tell return perimeter. This is the way how I'll create the find rectangle perimeter method. Also, this is the shape class. This is the square class. This is the square class. Next, this is the circle class. This is the rectangle class. And now coming to the shape application.java. Very first thing what we have to do, we have to achieve polymorphism. Means we want 1 ratio to many relationship. All the classes are extending to the shape class, extends shape. Circle also extends shape. Rectangle also extends shape. So here first I will create the reference of shape type, shape maybe sh. Next, here I will create the object of circle. Then I will create the object of square. Then I will create the object of rectangle. See, again, it is not required that always you have to create that reference variable. You can do it without reference variable also. Directly you can tell sh is equals to new square. Like this, you can mention. And then here you can tell directly sh dot draw method, sh dot find area method. This is which method we are calling? Inherited. Which method we are calling here? Overridden. Now I want to call child specific. What I should do? sh we have to convert to what type? Square type. So here I will tell sh, please get converted to square type. And then here completely I will use to call the method find square perimeter. In the same way, now I will tell sh, you have to point towards what? New circle. And then here I will tell sh dot draw method, sh dot find area method, sh dot, or here then I will tell again circle sh. This completely I will take to call the child specific method, that is find circle perimeter. Next I will tell here sh is equals to new rectangle. Next sh dot draw method, sh dot find area method. Next again here I will tell rectangle sh dot find rectangle perimeter method. This is the way how I'm writing the program. Now if in case I'll execute this, you know very well what is going to be the output. Drawing a shape. Okay. Why? Because we have to print it directly. So system.out.println sh dot find area, because it is returning, right? So we have to print it. Whatever it is returning, we have to print it. In the same way, here also I will tell system.out.println. In the same way, this also I'll put in the system.out.println. This also I'll put in the SOP statement. This also I'll put in the SOP statement. And this also I'll put in the SOP statement. I'll save the program. If in case I'll execute now, you can see the output. Drawing a shape. This is the, this much we are getting from square. This much we are getting from circle. This much we are getting from rectangle. But still in our program, what is there? Code redundancy is there. We have to solve this. Now for solving this, what you would have done? You would have created a separate class. In the separate class, you would have created a separate method. See again, if you want to create a separate class, you can create. If you don't want to create a separate class, in the same class also you can write the program. There is no problem there. So here also in the same class only I can write one program. Maybe here I will tell public static void do activity method. Correct? Like this only you have written the program. Only thing is there you have written in a separate class. Here I am writing in the same class. Okay. From which class we have to, from which method we have to call this? Main method. And because we are calling it through the static method, this method also should be static method. That time we are creating the object of the class and we are calling. Now I don't want to create the object, so I'm using or I'm creating this method as a static method. Any of the approach you use, both are same. Anything you can use, depends on you. Main thing is that inside this activity method or do activity, whatever the separate method you have created, what you have to do first? You have to put the parent type reference as a parameter. After this, whatever is repeating again and again, sh.draw, SOP, sh.find area, sh.draw, SOP, sh.find area, sh.draw, SOP, sh.find area, you will have to take and you have to put it over here. And then you can remove it from here. This also I will remove it off. Now this much is left. This shape sh also we have already told in the separate method. So remove it from here, not required. Now next what? Here we have to create the object of the square class. So here I will tell square sq is equals to new square. Here I will tell circle cl is equals to new circle. Circle cl is equals to new circle. Here I will tell rectangle, maybe rc is equals to new rectangle. Is it clear, everyone? These statements also we will take it and we will put it inside this particular method. This statement also I will take it. I'll put it inside a separate method. This statement also I'll take it and I'll put it inside a separate method in this particular way. Now we are having these classes: square class, circle class, and rectangle class. Whatever these classes we are having, now what we should do? I have to call which method now? Do activity method. Do I need to create the object? No, directly I can call it because it is which type of method? Static method. So what I can tell here? Tell me. Shape app dot do activity. That is also not required. Directly you can tell what? Do activity. First I will pass which reference? SQ. Next again do activity. Which reference? CL. Next again do activity. Which reference? RC. So here first I am passing for the square, then I am passing for the circle, then I am passing for the rectangle. Also here I will just print some lines which will work as a separator. I'll just copy this and I'll paste it here also. Now the question is, what will be the answer for this? How many of you have written the program like this, first of all? That's all. You have not written the program like this. Raise your hand if in case you have written the program like this. That's all. Other students? Huh? Okay. Other students have written these statements inside the main method, is it? Okay. Why you have not written here? Because it is not common. Whatever. If in case you are written in a separate method, that's fine. But if in case you are writing over here only, assume that I want to write this in the do activity method only, then what we can do? Maybe like this I can write the program. But now you tell me, you are sending whose reference? Square reference. Please understand this very carefully now. Pay full attention over here. You are sending which reference? Square reference. So now this SH is pointing towards what? Square. So it means SH is equals to SQ. That is only the meaning of this. Shape is pointing towards what? Square. Again repeat. Shape is pointing towards square. Again repeat. Shape is pointing towards square. Remember this. So when you are telling draw method, whose draw method? Square draw method. Very good. When you are telling find area method, whose find area method? Square. Super. And then you are changing SH, get converted to square and call which method? Find square parameter method. Again inside which class? Square class. You are not stopping there. You are continuing. Now you are telling SH, get converted to what? Circle. But SH is pointing towards what? Square. Understand this? As of now, here, when you are sending SH, you are sending SQ to SH. SH is of what type? Shape type, parent type. So parent can point towards child. But now when parent is already pointing towards child, how you can tell one child, you become the type of another child? Which type of downcasting? Which type of casting it is? Left, right casting. Either it can be upcasting or it can be downcasting. Means parent to child or child to parent. Child to child, what type of casting it is? So if in case I'll execute this program, see the output here. In which statement we are getting and see the exception name also. Class cast exception. What do you mean by cast? What do you mean by cast? Cast. Typecast, typecasting, upcasting, downcasting. Cast means what? Conversion. Means one exception is happening. Sir, what is exception? Later point of discussion. As of now, remember exception means mistake. What it is? Mistake. So one mistake is happening due to what? Converting one class into another class. Again, I'm repeating how you have to read it. One mistake is happening when we are casting, when we are converting one class into another class. To which class? To which class, sir? It is written here. A square class cannot be converted to which class? Circle class. Both are brother and sister. Not possible. Parent to child possible. Child to parent possible. You are never giving your business to your brothers and sisters. Anyone is giving? No, you will inherit from your parent. You will never inherit from your siblings. Is this clear with everyone? In the same way, here also it is creating a problem. And then, sir, what to do? This is a problem statement now in front of us. How we can solve this? How we can solve this means, in this particular program, I have to use control constructs. See, again, coming back on the same point, that again we have to use the control constructs here. 1 second. All right, so here now let us see how we can use this control constructs in this particular program to solve our problem. In control constructs, can you think? I'm giving you 30 seconds of time. You already know the solution for this. I just want you to think what might be the solution. I don't want proper solution. Proper solution I will tell. I want you to analyze and give me the logic. That's why this might help us think. I will give you a hint also. Or first you want to think? First you want to think. Okay, think. After 30 seconds, I will give you the hint. You don't tell me anything. Just think in brain. Don't think from mouth. Don't speak anything. Just think. Recall what is the problem statement. Like this only you will become developers. Nothing else. You have to think. Recall the problem statement. What is the problem statement? Understand the problem statement properly, and then try to think for a solution here. One hint I already gave, control construct also. Don't speak anything. How here inheritance is happening between parent and child. In the class also discussion should happen between teacher and student. Student to student, discussion not allowed. Done, time up. I will give you one. How many of you thought? How many of you thought? Okay. Wrong or right, that's a different story. I'm not asking correct or incorrect. How many of you thought at least? Okay. I'll give you one more hint. Let us analyze how, as a developer, we should analyze this problem statement. As a developer, first we have to focus on the problem statement. What is the problem statement? If I am passing the reference of SQ, then SQ is going and sitting in what? SH. SH initially is of what type? Shape type. Shape is what for SQ? Parent. Shape is a parent of square. So shape, which is a parent, is able to point towards what? Square. Perfect. After that, parent is able to call the inherited method, find area. Sorry, draw method first. Parent is able to call the draw method, find area. Using parent, you are able to call the overridden method, find area. Using the parent, you are able to call the child specific method of the square. Correct? But after that, what SH is? Square. Now, because you have converted SH to what? Square. Now you're telling square. Square get converted to what type? Circle type. So now again, think and tell. When you are passing SQ, which methods you want to call? This much you tell me, answer you will only tell. When you are passing SQ, which methods you want to call? Draw method you want to call? Remember. Find area method you want to call? Remember this. Find square perimeter method you want to call? Yes, no. Yes. Find circle perimeter? No. Find rectangle perimeter? No. So which methods you want to call? Draw, find area, find square perimeter. Very good. Let us come to the next point. Next, when I will pass CL, circle, which methods you want to call? Draw, find area, find circle perimeter. Perfect. When you want to pass RC, which methods you want to call? Draw, find area, find rectangle perimeter. I have given you the hint. Draw, find area, always you are calling. But sometime you are calling find square perimeter. Sometime you are not calling. When you are calling, when you are not calling, now think on these lines. Now try to come up with an answer. Full solution only I have given. Just think how it is going to work. Don't speak, don't speak, don't speak. Think. Randomly I'll pick someone and I'll ask. From which school you are? Sit. You people keep on thinking. From which school you are? In your school, teachers used to tell, keep finger on your lips. Yes or no? Yes. Same thing I'll do with you also. Done. Time up. There, blue color, the student in the hoodie. Yes. Hi. What is the solution for this? If else is a solution. Okay. If else what? I'll just type if else. Solution I'll get. Then if SH equal to SQ, we have to call find square parameter. Okay. Else SH equal to CL. Okay. We have to call circle parameter. Okay. Next, else rectangle parameter. Please see. Simple. If in case you are passing what? SQ, then you have to call what? Square parameter. Otherwise, else if you are passing CL, you have to call what? Circle parameter. Else you have to call what? Find rectangle parameter. Simple if else condition, but few things. What we have to understand here, let us see. So here again I will come up on this program, and here I will tell if in case SH is equal to SQ. Okay. Like this I will write. Whatever you told, I am writing. Else if again SH equal to CL. Okay. Then I will put this. Otherwise, else I will write this. But it's giving some errors. Why it is giving errors? Why it is giving errors? Which method? So, see, very simple, right? We know the concept of local variables, instance variable. What do you mean by local variable? The variables which are present inside the method. What are instance variable? The methods which are present outside the method, directly inside the class. In this particular program, what is this square, SQ, CL, RC? Local variables, instance variables. Local variable of which class? Main method class. So when they are present inside the main method, how you can access it outside the main method? Understanding? So here this double equal to is not going to help you. Rather, here we have to understand a different thing now. We are going to use one different operator. A different operator is what we are going to use. Double equal to operator we will not use. A different keyword we are going to use, and that keyword happens to be instance of keyword. What is it? What is this keyword? Instance of. So many times you would have learned, or so many times you would have heard this. Instance means object. Instance means object. So again, how we will read it? We will read it like this. If sh is object of square, then I have to call square class method. Otherwise, else if sh is object of means instance of circle, then I have to call this. Otherwise, I have to call this. So here one keyword we are using. Which keyword we are using? Instance of. So what this instance of will check? Instance of will check this reference variable belongs to this object or this class or not. If in case it belongs, it will give you what? True. Otherwise, it will give you what? False. Let us execute the program now. If in case I'll execute the program, you can see first drawing a shape, and then you are getting all this from the square class, then all this from the circle class, then all this from the rectangle class. Maybe what I will do, I'll do one more thing here. I will tell return area. Before this, I'll print one message, system.out.println, area of square is. Like this, I'll print. Here I will tell perimeter of square is. Here I will tell area of circle is. Here I will tell perimeter of circle is, so that more properly you will understand this. Here I will tell area of rectangle is, and then here I will mention perimeter of rectangle is. I'll save it. I'll come back here. If in case I'll execute, now you can see first we are getting everything from the square, then we are getting everything from the circle, then we are getting everything from the rectangle. In this way, this is the most efficient program of polymorphism which we can write, where we are able to call inherited method also, overridden method also, child specific method also. We have upcasting also in the program. Do we have upcasting? Yes. We have downcasting also in the program. Also, we are not having any code redundancy. And also we have created the logic by using which keyword here? Instance of keyword or instance of operator, anything you can tell. What instance of operator will do? It will check whether a reference variable belongs to a specific class or not. If it belongs, it will give you true. Otherwise, it will give you false. Please take down in your notebook. In the above program, code redundancy exists. In the above program, code redundancy exists. Code redundancy exists while calling the inherited and overridden methods. In the above program, code redundancy exists while calling inherited and overridden methods. While calling inherited and overridden methods. Hence, we should do. Hence, we should remove code redundancy. Hence, we should remove code redundancy by using a separate method. And also call the child specific methods, and also call the child specific methods and also call the child specific methods by using the instance of keyword. By using the instance of keyword. By using instance of keyword. After this, just make a note of this particular program. Then copy this, everyone. After this, take down one thing in your notebook. Instance of keyword is used. Instance of keyword is used instance of keyword is used to check instance of keyword is used to check whether a reference variable instance of keyword is used to check whether a reference variable belongs to a specific class or object belongs to a specific class or object or not belongs to a specific class or object or not if it belongs to a specific class if it belongs then it returns true. If it belongs, then it returns true. Otherwise it returns false. If it belongs, it returns true. Otherwise it returns false. All right. So now we have understood properly that what do you mean by this polymorphism, how this works, what is upcasting, what is downcasting, what is method overriding. All these things are done now. Coming to this concept of method overriding again. See, this method overriding we are doing in so many different classes. For example, here also find area method we are overriding. But in whichever way we want, however we want, can we do the method overriding? No. There are some rules, there are some parameters which we have to follow. There are some regulations which we have to follow whenever we are trying to achieve method overriding. So let us understand that what are the rules to follow method overriding concept. Take down in your notebook the next subheading is rules of method overriding. Rules of method overriding. Rules of method overriding. Now let us understand these rules very properly. Assume that here I am having one class by the name of parent. Next, I am creating here one more class by the name of child. Next, assume that I am creating one more class by the name of parent child application, inside which main method is also present. So one class is parent class, another class is the child class, and another class is the parent child application class. Now let us understand what we have to do here. In this parent class, let us say that I am having one method here. That method happens to be display method. And inside this, I will print one message also saying system.out.println inside parent class display. This is the child class. Inside the child class, first I will extend it to the parent class. And then whenever I want to do the method overriding, it is always a good practice to write one annotation that happens to be what? @override. And now here in the @override, I have to mention same thing, void display method. And then here also I will tell system.out.println. I will override it and I will print inside child class display method. This is the parent and child application. In this parent child app, First thing, I will create the object of the child class. Child ch is equals to new child. And then here I will tell ch dot display method. Tell me what will be the output? What will be the output? Inside child class display. If in case I will execute it properly, it is working inside child class display. Method overriding is happening or not happening? It is happening. Okay. Also see what this @override will do. For example, here assume that I will tell display 1, 2, 3. And then I will write the program. Is it giving error to you? Yes or no? Yes. Why? Because this method is not overridden method. And how come you can use annotation @override here? So whichever method is really overridden method, only with that method you can use @override annotation. Otherwise, it will give you what? Error. And what error? See the error also. The method display 1, 2, 3 of type child must override a super type. So it must be a overridden method. It is not possible that it is a child specific method. So here I will tell correct. It is overridden method, like this I will mention. Now what I will do here is assume that I will mention. Now let us understand the rules very properly. Pay your full attention here. Here I will tell the access modifier for this happens to be public. What is access modifier? Public. If in case I will tell public, am I getting the error? Yes or no? Yes. Okay. Here assume that I will remove public. Am I getting the error now? No. Okay. Here assume that I will give a protected. I will give what? Protected. Are you getting an error? Yes. Assume that here also I will tell the same thing. Are you getting an error now? What does it mean? Whatever the access modifier you have told in the parent class, same access modifier you have to tell it in the child class also. If in case you are changing the access modifier, it is not going to work. Is this clear with everyone? So in the method overriding, in the parent class method, whatever the access modifier you have told, same access modifier you have to tell it in the overridden method present inside the child class. Take down rule number 1. Rule number 1. Rule number 1, and then continue. In method overriding, the access modifier in method overriding, the access modifier of parent class method in method overriding, the access modifier of the parent class method and child class overridden method, the access modifier of parent class method and child class overridden method must be same. Must be same. Okay. And after this, just make a note of this program. Then copy this, everyone. All right. Now let us understand the second rule. Take down rule number 2. Rule number 2. To properly make you understand this rule number 2, what I'm going to do here is I'll create one more class. This class name I will tell here is child2 class. This class name also I will rename it as child1 class. Now is it visible? So one class I am having as child1 class and another class I am having as child2 class. Like this, two child classes I am having. One is the parent class, one is the child1 class, one is the child2 class. Child2 class extends parent class. Okay. Now next what? In this child2 class also, I want to override one method. So here I will tell @override. Maybe same thing I will write it. Here I will tell inside child1 class display, inside child2 class display. If I will call this method, what will be the output? Inside child1 class display. If I will call this method, what will be the output? Inside child2 class display. Okay. Now, this is a method inside which or in which, what is the access modifier we are using in the parent class method? Protected. According to rule number 1, whenever we are doing access, whenever we are overriding anything, we cannot change the access modifier. So here I am having the same access modifier, protected. Here I will tell we are having the same access modifier. But here I will change it. Here I will have a different access modifier. What different access modifier? Here I will tell instead of protected, it is what? It is default. Possible or not possible? Possible, not possible? Not possible. If in case here I will tell default, it is not there. Public I will mention. Possible, not possible? Huh? Possible, not possible? Possible. Read rule number 1. In method overriding, the access modifier of parent class method and child class overridden method should be same. Okay. Parent class method protected, child class overridden method public. Is it same? Not same. But are you getting any error? You are not getting any error. One more thing we will see. This is which access modifier? Protected access modifier. I will remove protected. Tell me where you are getting error. Anywhere are you getting the error? No. So what is the access modifier here? Default. Here protected, but no error. Here public, no error. And if in case you will see, program will work also. Here I will create one object of the child1 class. Child1 maybe ch1 equals to new child1, ch1 dot display. I'll like this, I'll create the method of or create the object of child2 class. ch2 dot display, and then I will execute it. You are getting inside child1 class, inside child2 class. So program is also working fine. And what is this magic, sir? Very simple magic, very simple rule it is. Parent class method access modifier and child class access modifier can be different, provided you are increasing the visibility, you are not decreasing the visibility. So if you want, you can have the different access modifiers only in one scenario. What is that scenario? The visibility is getting increased, it is not getting decreased. What is the visibility here? Default. Tell me Protected is having more visibility than default or less visibility? Only the students who are present in that class, they can tell that there are something called as 4 access modifiers. If in case you are absent, it's okay, because you are coming to the class now. At least for attendance sake, listen, there are 4 access modifiers in Java. One is public, protected, default, private. What is private? In encapsulation, we have learned. What is encapsulation? Nothing. One simple topic is there of Java. There is something called as object orientation pillars. What is object orientation pillars? Nothing. You are seeing, right? These 4 pillars. This is encapsulation. That is inheritance. One is polymorphism. One is abstraction. What is the use of encapsulation? In your home, when you are coming out, when you will put lock, that is called as encapsulation, providing security. What is inheritance? You and your parent, what relationship you have? Parent and child, that is inheritance. Polymorphism, you are son or daughter of your parent. For me, you are a student. For your friend, you are a friend. For them, you are. That is 1:many relationship. That is polymorphism. What is abstraction? You are lucky that now only you came to the class. So abstraction we'll learn later. Because I'm seeing many new faces. I'm seeing few faces for the first time. I don't know why you came now in the class. Just for attendance? Actually, this also, when I started the class, no, I thought that maybe students will come here in Bangalore for getting the placement or for learning purpose. But now I came to know you are coming, you are sacrificing so many things just for one attendance. So that because of attendances happening offline, so much strictness has come that attendance hako also is not happening. Otherwise, one group, one student is in the class, 10 students are in PG. That one person who is coming, putting proxy for everyone. Okay, come back to the concept again. So here we are having one parent class in which the access modifier is what? Default access modifier. Here the access modifier is what? Protected access modifier. Here the access modifier is what? Public access modifier, but then also it is possible. Now let us understand here. I will tell the parent class access modifier as protected. This is protected. If in case it is a protected, can I have the same access modifier? Yes, rule number 1. Can I have the public access modifier? Yes, because visibility can be increased. It cannot be decreased. If in case I will remove public, now it is not possible. And see the error. Cannot reduce the visibility of the inherited method. Why? Because from protected to default, visibility will be increased or decreased? Visibility will be decreased. Like this, you think and tell if you are understanding it correctly. If in the parent class, I am having one access modifier as public, what options you have in the child classes? Only one option. What it is? Public, because anything other than public will have the lesser visibility. So here also you have to tell same thing. See, you are getting an error now. You will mention the public, error gone. Here also you tell public, error is gone. If in case here you are having protected, if in the parent class you have protected, what and all you can tell in the child classes? Either the same thing, protected, or you can tell public, or means either the same, protected, or you can tell public. If in case in the parent class, the method is having access modifier as default, what you can have in the child class? Same, default or protected or public, like this. Now very quickly tell me, if in case in the parent class, the method is private, what you can have in the child class? Private, default. First to tell me how private will be inherited. Here you are telling private. Can you inherit and override the private data member? So first you tell me how you will override, then I will show you the rules of private. So in the interview also, please don't flow in the emotions. Sir, public, sir, public only. Protected are protected and public. Defaults are default protected public. Private, so private default protected public. Door will open, you will be sent out. So if in case it's a private, you cannot inherit. Rules of inheritance. Private data members will never be inherited or will never participate during the inheritance. So here, what we are understanding is something like this. If in case I am telling here, let us say protected. Assume that I am telling protected. Here I am telling protected, and here I am not telling anything. So here you are having an error. Why? Because visibility cannot be reduced. Please make a note of this. Take down first rule number 2. Rule number 2. Parent class method, or take down like this. In method overriding, parent class method and child class overridden method. In method overriding, parent class method and child class overridden method can have different visibility, or access modifiers, can have different visibility or access modifiers, provided the visibility of overridden method, is getting increased. The visibility of overridden method is getting increased. Full stop. Continue. If visibility is decreased, then it will generate compile time error. If visibility is decreased, then it will generate compile time error. After this, please make a note of this example in your notebook. After this, take down one note in your notebook. If parent class method is public, if parent class method is public, settle down fast, quickly. So if in case you are taking break, going to washroom, that is fine. Standing outside, sitting on sofa, that is not fine. Going outside, do your work, whatever work you have outside, come back immediately. Don't wait, my friend is inside, I am waiting, let her or him come. There also friendship you are showing means I don't know which type of friendship it is. And this friendship looks good on the girls. When one boy will tell, sir, just going, sir, they want to go. 2023, anything is possible. Just take down here. Online students will not have any idea, sir, regarding what you are speaking. Please take down one note. If in the parent class method is public, if parent class method is public, then child class overridden method can be. If parent class method is public, then child class overridden method can be. You write. You complete the sentence. If parent class method is public, then child class overridden method can be public. Can be public. Next point. If parent class method is protected, if parent class method is protected, then child class overridden method can be. If parent class method is protected, then child class overridden method can be. Complete the sentence. Can be protected or public. Can be protected or public. Can be protected or public. Next, third point. If parent class method is default, if parent class method is default, if parent class method is default, then child class overridden method can be. Then child class overridden method can be. Child class overridden method can be default, protected, and public or public. Default, protected, or public. Default, protected, or public. Regarding private, is it required? Is it required? Not required. Why? Because private, if in case one method is private, it will never participate in the inheritance. If it is not getting inherited, it will never get overridden. If in case it will never get overridden, it will not come in the rules of method overriding. Let us move to the next rule, rule number 3. Rule number 3. Now let us understand what this rule says. This is a very, very important one. Here assume that this child 2 I don't want as of now, so I'll just remove it off. Let us have one parent class, one child class. In the parent class, let it be public. This also let it be public. Okay. So both are having the same access modifier. Now, in the parent class method, the return type is what? What's the return type? Void. In the child class overridden method, what is the return type? Void. Let us say I don't want void. I want to give here float. What I want to give? Float. If in case I am giving float here, what does it mean? This method has to return a floating point. So here assume that I will tell return 5.5f. Sir, why you are telling the return statement? Just because I am telling here what? Float. But still, if in case you will see, you are getting an error. Let us take the cursor on the error. What it's telling? The return type is incompatible. It is not supportable with what class? Parent class. Which method? Display method. Okay. Let us try to give here some other return type. Here I will tell int. Here what I have to do? Return 5. Let us say. Why I'm telling return 5? Because the return type is integer. I have to return some value. So some value I'm returning, some random value I'm returning. But still, is it working? Not working. So what does it mean? The return type of parent class and the return type of child class overridden method must be same. It cannot be different. Please take down in your notebook. See this also. Let us say here I will have the child 2 class as well. Child 2 class, I will put it over here. In this child 2 class, here I will mention this is public int display, and here I will tell return 10. Can I return a different value? Can I return a different value? Yes. Any error in this? No. So it does not depend on what value you are returning. It depends on the return type. Here this is int, this is int. So there is no error. So here I will first tell this is error because return type is changed. Here there is no error because return type is same. Now take down in your notebook. In method overriding, parent class method, in method overriding, parent class method and child class overridden method, parent class method and child class overridden method must have same return type. Must have same return type. Must have same return type. If it is different, then it is not allowed. If it is different, then it is not allowed. Then it is not allowed in method overriding. If it is different, then it is not allowed in method overriding. For example, please copy this example in your notebook. Try to write it by your own. Is it copied, everyone? Take down the last rule of method overriding. Rule number 4. Well, if you will see rule number 3 states a very simple thing, that whatever the return type is present in the parent class method, if in case in the child class you are overriding that method, then you should have the same return type. If you are trying to change the return type, it is not going to work out. That is what rule number 3 says. Rule number 4 says a child class overridden method can have a different return type. Child class overridden method can have a different return type, but terms and conditions applied. So like how your rule number 2 is telling that you can have different access modifier, but terms and conditions applied. What are the terms and conditions? Visibility should be increased, visibility should not be decreased. Something like this only. There is a rule related to the return types also. You can have a different return type provided the return types are of covariant return types. Which types? Covariant return types. Now, sir, what do you mean by covariant return types? Let us understand this very properly. See, what I will do here is I will create two classes. Where that went? Okay, here I will create two classes, two more classes. Assume that one class I will mention here as a, let us say as a, okay, electronic device, something like this. And then I will create one more class here as a laptop class. So two classes I am having. One class is electronic device and another class is the laptop class. Both of these classes I will bring here on top. One is the electronic device class. Another one is the laptop class. Now, whatever these classes are there, electronic device, I will not put anything inside this class. It is an empty class. In the same way, in the laptop class also, I will not put anything. I am not creating these classes for keeping something. They are totally empty classes. Now again, think and tell, is there any relationship in between electronic device class and the laptop class? As of now, there is no relationship. We will establish a relationship by telling here extends electronic device. Correct. Laptop is a electronic device. I have told you. Extends, you always have to read as is a relationship. So here laptop is a electronic device. Now whatever the program I am going to write now, it might look very weird to you because till now you would have not seen any program like this. But again, if you want to understand this rule, you have to see this particular program. In this parent class method, I will tell the return type is not int. Rather, the return type is the electronic device. What is the return type? Electronic device. Now, because I am telling that return type is the electronic device, I cannot tell return 5. Rather, what we have to do? We have to return the electronic device type object. What we have to return? Electronic device object is what we have to return. So here first I will create one object, new electronic device. One object I have created. Whatever object I have created, this object only I will return. So here like this I will mention. Is it clear? So what I am doing? Very simple. Forget about everything, whatever you are seeing, don't see anything. Only see this. I am creating one class of what type? Electronic device. And here I am telling this is a method which is not returning int, byte, short, float, double boolean, char or string. Rather, this method is returning electronic device type of object. Because I am telling it is returning electronic device type of object, I am creating one object, new electronic device, and I am returning it. Any problem in this? Any problem in this? No problem. Moving to the child class. Child one class is extending to the parent class. Now here I will tell that I am having the same return type, electronic device display. And then again, what we have to do? We have to return same thing. Electronic device object is what we have to return, like this. So in this particular way, I am writing the program. In this particular way, I am writing the program. Now, coming back to our class. This is a child class which we have created. And this is the display method which we are writing. Here I will remove this. I'll bring it on a little bit top. Now coming to the child 2 class. See, here there is no problem because rule number 3 is getting followed. Parent class method return type and child class overridden method return type must be same. It is same. Display method here it is returning electronic device. Display method here is returning electronic device. Moving to the child 2 class. Child 2 class method will not return electronic device. It will return something else. For example, int is what it is returning. Now, if in case it is returning int, is it possible that electronic device is the return type of the parent class? Int is the return type of the child class? No. But it can return the object of laptop class. And here, what I have to tell? New laptop. Like this, I will mention. Any problem in this? No. Anywhere, are you getting any error? So you can see, although parent class method is having a different return type, child class overridden method is having a different return type, but then also it is not giving any error. Why? Because here you are understanding that there is something called as covariant return types. Now, what do you mean by covariant return type? Covariant return types are such return types which have parent and child relationship between each other. What they should have? Parent-child relationship. Are we having any parent and child relationship between electronic device and laptop? Yes, that only we have first established. For example, let us say I will remove this. See what will happen if in case I will remove this. Is there any parent and child relationship in electronic device and laptop now? No. As soon as I told, see, it is giving an error to us. Because now, are they covariant return type? No. So what are covariant return type? Covariant return types are such return types which have parent and child relationship. If in case in the parent class method is throwing a return type or it is having a return type, child class method overridden method is having a different return type. It is allowed, it is possible, provided they are covariant return type. Next question will be asked, what is covariant return type? Explain. Covariant return types are such return types which have parent and child relationship. Now, why int and float was not possible? Because int and float are not parent and child, as simple as that. Is it clear with everyone? Please make a note of this. First, take down rule number 4 and then continue. During method overriding, during method overriding, during method overriding, parent class method, during method overriding, parent class method and child class overridden method, parent class method and child class overridden method, parent class method and child class overridden method can have different return types, can have different return types can have different return types provided the return types are covariant return types. Provided the return types are covariant return types. Are covariant return type. Full stop. Next paragraph. Covariant return types are such return types. Covariant return types are such return types covariant return types are such return types which have parent and child relationship. Covariant return types are such return types which have parent and child relationship. Example. Now see how you have to copy. First you have to copy these classes. Class electronic device, first you copy this. Then copy class laptop extends electronic device. And after this, copy parent child 1, child 2. Please make a note of this. Also, I'm starting the attendance for Java. Please mark your attendance. For today, without connecting to Wi-Fi also you can mark. I have switched off that service because there was some issue in the Wi-Fi. So directly using your mobile network, you can mark for today. Now the students who came just for attendance, they are thinking, shit, why we came today? Attendance, how come message would have come? We could have marked attendance from PG itself. All the offline students, please do one thing. Try to connect with the Wi-Fi, CodeNest Wi-Fi, and let me know how many of you are able to connect. A testing is going on. Just connect with the Wi-Fi and let me know if in case you are able to connect with the CodeNest Wi-Fi or not. Wi-Fi name is Code Class AP. All of you are done. You have copied this. Make it fast. Copy it fast. How many of you are able to connect now? Wrong question. How many of you are not able to connect? Okay. What it is showing? It is just keep on processing. Is it showing some error message? Access denied. Again, please raise your hands. How many of you have connected? Please raise your hands once properly. I just need a count. One full hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All of you have copied this? All right. So if in case you will see now, we have concluded with few things in our conceptual layer of Java. Let us see what and all we have finished. First, we started learning with encapsulation. After that, we have learned what do you mean by private data member. Then we have learned what do you mean by public setter and public getter. Then we have understood what do you mean by constructor. What do you mean by constructor chaining? After that, we have started with the understanding of the inheritance. And then we have learned what do you mean by parent and child, single level inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance, cyclic inheritance. Then we have understood about the extends keyword. We have understood about the super keyword. We have understood about the super method. We have understood about the this keyword. We have understood about this method, constructor chaining. Next, we have understood about final keyword. Yes. Final keyword is done. Perfect. Next, we have understood about the static keyword is done. Static keyword is not done. So next we have understood about the polymorphism. We have started. In the polymorphism, we have understood about what do you mean by one ratio to many relationship? What do you mean by upcasting? What do you mean by downcasting? How upcasting will happen? How downcasting will happen? We have learned about the 4 different access modifiers: public, protected, default, private. And now today, if in case you will see, we have learned about majorly focused on rules of method overriding, where we have understood that whenever we want to achieve method overriding, that time few rules we have to follow. Rule number 1 says parent class method and child class method return type must be same. Rule number 2 says parent class method and child class overridden method can have a different return type, provided, or access modifier you can take should have the same access modifier. Rule number 2 says can have different access modifier, provided visibility is getting increased, it is not getting decreased. So if parent class is public, parent class method is public, child class method only can be public. Parent class method is protected, child class method can be protected or public. Parent class method is default, child class method can be default, protected, and public. Next, we have understood about the return type should have the same return type. Rule number 4 says if different return types are there, it is allowed, provided the return types are of what type? Covariant return type. What do you mean by covariant return type? Which have parent and child relationship. This much is what we have covered as of now in Java. If in case you will see in this inheritance, we are working with one relationship. This relationship is called as is a relationship. In this example also we have created, we are having is a relationship. In between which classes we are having? Electronic device and laptop class. So I can tell laptop is a electronic device. Previously we are having is a relationship in between maybe shape and circle class. Circle is a shape. What is the relationship between developer and backend developer? Backend developer is a developer. Software engineer and front-end developer? Front-end developer is a software engineer. Maybe wallet and payment application? Wallet is a payment application. Like this, we have created many different examples, many different classes where we are having this is a relationship. Like this, I will ask few more questions. Keep on telling that what relationship is present in these examples, in these scenarios. Student and human. Student is a human. Book and, okay, maybe a Java book and a notebook. Java book is a notebook. Okay. Maybe bike and vehicle. Bike is a vehicle. Car and four-wheeler. Car is a four-wheeler. Okay. AC and electronic device. AC is an electronic device. Student and a laptop. Sorry? Voice is not coming to my ear. Sorry? Student is a, okay, laptop and hard disk. Laptop is a hard disk? No. Hard disk is a laptop. Okay. Bike and engine. Bike is an engine. No. Bike, engine is a bike. No. Okay. Notebook and bag. Okay. Pen and ink. Pen is a ink. Ink is a pen. So now in this real world, all the relationships are getting satisfied with is a word? No. Few relationships are getting satisfied, but there are many other relationships where is a relationship will not work. There, a different type of relationship we have to understand that happens to be has a relationship. Which relationship? Has a relationship. Coming back on the same example, bag and notebook. Bag has a notebook. Student and brain. So loudly you are telling. Okay. Pen and ink. Pen has a ink. Laptop and hard disk. Laptop has a hard disk. Student and laptop. Student has a laptop. Bike and engine. Bike has a engine. So now you are seeing that everywhere is a relationship is not there. And few scenarios we are having something called as has a relationship. Whatever is there in the real world, as it is, it has to be replicated in Java also, because Java is object-oriented programming language. Object-oriented programming language works exactly how this real world works. So now when we are having inheritance to handle is a relationship in the real world, like this, what we have in Java to handle, to deal with the has a relationship is called as the concept of aggregation and composition. Concept of what? Aggregation and composition. On the new page, take down the heading as aggregation and composition. Aggregation and composition. Just take down the heading and close your notebooks. We'll learn it in the tomorrow's class, in the next class. So today I will halt my technical discussion for Java over here. Online students, please join the front-end sessions. I'm ending the Java class. Please join the front-end class.